Hello everyone. Today we are going to continue our notes with the three solution types: one solution, infinite solution, and no solution. So at the top of this page, I've actually given us a little bit of a shortcut or a little way to remember the difference between the three. So when you have one solution, you're actually left with a variable, and that variable equals a number. The number could be positive, negative, or zero. It could be a fraction, it could be a decimal. Infinite solution, as you can see, there's no x variable left, but you have two numbers, and those two numbers will be equal to each other. And then no solution, again, there's no x variable left, and there are two numbers, but the two numbers are different. That's what it means by A equals B. So we have three different equations. This equation is going to lead to one solution. This equation is going to lead to infinite solutions. And then this one's going to lead to no solution. So just looking at this first equation, and it says one solution, what do you notice about the equation? And remember, we talked about the variable coefficients, and that's the number attached to x. So what I notice here is that our variable coefficients are different. And that's kind of what we talked about in our last class day, is that our variable coefficients, when they're different, leads to one solution because there'll be an x left over. So now we're going to solve it. So I'm just going to rewrite the problem here and solve it. So I have 7x minus 3 equals 5x plus 5. We have variables on each side, so I'm going to minus the 5x. It doesn't matter which one you get rid of, but I'm going to minus the 5x, and I'm going to be left with 2x minus 3 equals 5. I'm going to add the 3 to both sides and get 2x equals 8. Divide by 2, divide by 2, and be left with x equals 4. So now I'm going to check it, and I'm going to hope that when I plug 4 back into this equation, that the two sides will be equal. So 7 times 4 minus 3 has to equal 5 times 4 plus 5. 28 minus 3 has to equal 20 plus 5. 25 equals 25. Now you're going to think that's infinite solutions. That's infinite solutions because a number equals a number. That's not infinite solutions. What this is that it's a true statement. And that statement was made true when x equals 4. It's only true when x equals 4. So what is the solution? It's one solution when x equals 4. If I plug in 3 and I do 7 times 3, which would be 21, minus 3, which would be 18, and then 5 times 3, which is 15 plus 5, that would not make two equal numbers. It would not make a true statement. This is only true when x equals 4. So it's one solution when x equals 4. The next one that we're going to do is infinite solution. It says when a number equals the same number on the other side. So what do I notice about the equation? Well, what I notice is that, first of all, like one side is forward and one side is like backward. They are the same. But flipped. Here we had the 7x and then the minus 3, but then here we have a minus 3 and then the plus 7x. So I'm going to solve this equation. 7x minus 3 equals negative 3 plus 7x. I'm going to keep clearing my throat because I have a bubble stuck there. Sorry, guys. Hopefully it's gone now. All right, I have a variable on both sides. So I'm going to minus 7x on the left, minus 7x on the right. Oh no, the x's went away on the left, and I'm left with negative 3 equals negative 3, and the 7x's went away on the right. I'm left with negative 3 equals negative 3. There is no variable left. So what this tells me is that I check, is this a true equation or is this a false equation? And this is true. So what it means is that it has infinite solutions. So you're wondering, how am I going to check this if it has infinite solutions? Well, we're going to check it by just checking it, seeing if we can plug in different values and it would still make it true. Let's try 4, like we did on the first one. Let's try 4. 7 times 4 minus 3 has to equal negative 3 plus 7 times 4. 28 minus 3 equals negative 3 plus 28. 25 equals 25. So that is a true statement when x equals 4. Let's try a different number. Let's get crazy and try a fraction. 7 times 1/7 minus 3 has to equal negative 3 plus 7 times 1/7. So now I'm going to try it with 1/7. 7 times 1/7 is 1. Bring down the minus 3 equals negative 3 plus 1/7 times 7 is 1. Negative 2 equals negative 2. That's a true statement. Let's try one more. Let's try 0. 7 times 0 minus 3 equals 0 plus, that's not correct. Negative 3 plus 7 times 0. This is 0 minus 3 has to equal negative 3 plus 0. Negative 3 equals negative 3. That's a true statement. So we tried 3 different values. The first value we tried was 4, and that made a true statement. The next value we tried was 1/7, and that made a true statement. The next one I tried was 0, and even though I almost made a mistake, I plugged it in correctly, and that made a true statement. So what this tells us is that any number we plug in for x will make the two equations equal, the two halves equal. So what is the solution? Infinite solutions. Every number works. Makes it balanced, makes it true. Every number works. All right. So now the last one is no solution. And the first thing is what do you notice about the equation? Well, what I notice about the equation is that variable coefficients are the same. Here I notice the variable coefficients are the same, but more importantly, I notice that both sides were exactly the same. And so when I work through it, I end up with the two sides being equal. Here I notice that the variable coefficients are the same, the numbers are different. So we're going to solve it. 7x minus 3 equals 7x plus 5. Minus 7x from the left, minus 7x from the right. Those go away, and I'm left with negative 3 equals, my variables are gone. All right, so now I'm left with negative 3 equals 5. These two numbers are not balanced. They are not true. This is an unbalanced equation. So what that means is that there is no solution. There is no number that we can make these balanced. A lot of people think, well, what if we subtract 8 from this side? Or what if we add 8 to this side? No matter what we do, it won't be balanced. Okay, so we're just going to try some values, and see if it works. We can try the same values, we can try different values. I'm going to try the same, 4, 1/7, and 0. 7 times 4 minus 3, does it equal 7 times 4 plus 5? Well, no, because this will be 28 minus 3, and this will be 28 plus 5. So that doesn't work. Those are not equal. 7 times 1/7 minus 3 equals 7 times 1/7 plus 5. Well, that makes 1 minus 3. And will that equal 1 plus 5? Nope, that one doesn't work either. All right, let's try 0. 7 times 0 minus 3 equals 7 times 0 plus 5. 0 minus 3 equal 0 plus 5. Nope. So what this means is no matter what number I plug in, so I tried 4, I tried 4, I tried 1/7, I tried 1/7, I tried 0, I tried 0. They were not equal, not equal, not equal. So what that means is that there is no solution. No number makes the equation true. Balance, true, work, whatever. So just want to then kind of come back up and look at this. So here we were left with a variable, x, and it was true when x equals 4. So our one solution would be x equals 4. Our infinite solution, we got it equal every single time. The same numbers are equal to each other, so -3 is equal to -3. Our no solution, no matter which values we tried, we could not get it balanced. -3 equals 5 is not a true statement. They are not equal to each other. So a number, -3, does not equal 5. So we just practiced again our 3 solution types: one solution, no solution, infinite solutions. We solved them, we checked them, we noticed something about them, and then we said what the solutions were. Thank you for watching the video, and be ready to practice these 3 solution types when you are in building. Have a good day.